Quality, quality of service, quality of service. This quality of service topic, whenever you learn, you should always compare with the traffic police, traffic control, and traffic controlling methods. Because here also we are going to deal with traffic only. Here also it is traffic. So whatever you see in the road, you will see here also. What do you see in the road? You see a lot of people using the public road, and you see some signal lights. You even see speed breakers, and you see some police controlling, managing, maintaining the peace of traffic flow. What else we see? We see different signal lights with different meaning. Everything is here also in network quality of service. So traffic control is nothing but quality of service. Now, what else you see in the traffic? You see different type of users. Not all the users are same. Some are bicycle users. Some are motorbikes users. Some are four-wheeler users. Some are six-wheeler. Some are 10-wheeler. The vehicle size is not same. The payload is not same. The amount of size the vehicle consume in the road is not same. So according to the type of vehicle, there is a special service given on most of the well-developed countries. In some well-developed countries, you have a lane which is only meant for people who wants to travel long distance. Long distance, they don't take diversion in the middle, they keep going. For them, there is a lane. There is another lane for short distance people. There is another lane for bicycle, motorcycles, and there is a special lane for emergency. It depends on the location again, not in every road. Depending on the location, like if more hospital location, you also have an emergency lane. That is what quality of service is all about. I told you that about speed breaker, no? That is very important in quality of service. Speed breaker. Speed breaker, traffic lights. These are all what? Congestion management techniques. Congestion management techniques. You have traffic lights. Traffic lights are there so that you will stop sometime so that the congestion in the front will not go more. If there is no traffic light in some roads, that will cause congestion because people keep coming and the flow is not that fast. So what happens? Congestion. So what the police people do, they put a signal and stop you so that you won't go and add more congestion in the front. Same thing, speed breaker. It helps you to shape the traffic shaping. It makes you slow down. The speed breaker makes you slow down. Slow down. It's good. That reduces congestion. If everyone goes fast and go through a bottleneck place, difficult. Maybe you can allow ambulance or any emergency service to go fast, but not everyone. If everyone goes in high speed, not good. So what do we do when there is a congestion? When there is a congestion identified, or when there's a chance of congestion identified, immediately you stop or make the vehicle to go slow so that they all won't go and add more congestion. Slowing down the vehicle, maybe through orange light. When it is green light, you can go fast. When it is orange, you go slow. Or speed breakers. All these things that you see in the road, you will see here in network traffic engineering. You see, I told you you put different type of vehicle in different lane. Here also you see the lanes are called as queues. Different type of vehicles are called as different type of traffic. Not all traffic are equally important. Not all traffic are of same size. Not all traffic can be recovered if they get lost. There are various type of traffics. Some traffic are like OSPF hello packets. They are very important than any other traffic. Why? Because the routing protocol, are the one which gives you a path information for the traffic to pass through. So more than any other traffic, the management traffics are high weightage traffic, highly prioritized, very important traffic. More important than your business traffic, more important than your voice and video traffic, more important than UDP traffic. Management traffics are most important traffics. They always need the management traffics are the most important traffics. I mean, what was your question? I just gave one. OSPF is one example that manages the route. If OSPF don't maintain route in the routing table, if OSPF don't give routes to the routing table, traffic cannot pass through. They are very important. They are most important than any other traffic. For a router, route is very important. If there is no route, no traffic can be sent in the first place. So routes are because of routing protocol. So more than the user traffic, these management traffics are important. After this routing protocol and keep alive packets, hello packets, after this, the other management traffics like telnet, SSH, They are also very important than any other, more than your FTP, more than your HTTP. Telnet is very important because you are the owner of the device. Under all circumstances, you should be able to log into the router. If you are not allowed to log in, then you cannot control congestion, you cannot do any solution, you cannot take any solution when there is some issue going on with the CPU, with the router. So there are various types of traffic. After all this management traffic, voice traffic, video traffic, UDP traffic, they are important because these traffics are tiny traffics. Voice traffics are very small than FTP. Voice traffics are very small, and voice traffics use UDP. UDP traffics cannot be recovered if they get lost. So the user traffics, when you compare voice, video, multicast, UDP traffics are the highest priority in user traffic. After this only comes all other like HTTP, HTTPS, FTP, and so on. Ping. See, the user traffics are very important. In that, voice, video, UDP, multicast traffics are most important. The entire network is for user. I agree. User traffics are important. But for user to use the network properly, management traffics are most important. And then only this voice, video, audio, all those stuff comes. So we are not having same type of traffic. We have different type of traffic. As a result, you have to provide different level of service. You need to provide different type of treatment. Not the same level of treatment privilege you can have for all traffic. Like you have different type of lane on the road for different vehicle. Even in networking, we have different types of queues. Queue. You have different type of queue. Priority queue means a road with no speed break, no signals. That's priority queue. You can say a road which is dedicated only for the kings of the nation. Can anyone put priority? Sorry, can anyone put speed breaker in that road where the kings are going? Do they have the guts to do that? Do they have any guts to put some signal in the path? No way. In democratic countries, they do, but not in the countries where kings rule. Their roads are only dedicated for them, their family. No speed breakers, no signals, always open. And no one else can use that road. That is what called as priority queuing in networking. See, road is same, but in that road, a portion with a small side walls dividing the big road and saying this side no one should come. This is King's Road. King and his family can use it. No one else. Same way. In networking, you have a very big throughput, bandwidth path. In that, one portion, one small portion, will be reserved and always kept reserved and waiting for this tiny, teeny voice traffic to come. So this voice traffic will never get congested. This will always be flowing without any interruption, without any speed breaker. There is no slowing down, nothing in this priority queue. Whereas the other queues, parallel to this queue, there are other queues. One is meant for lorries, one is meant for car, the other one is meant for motorbikes. Those queues, they have turns to use the road. When the lorries are using the road, cars cannot use, bike cannot use. They need to wait for their signal to become green. So you have something like this, a round robin. This is the big road, and this is the priority queue. And this queue have got no signals. It will be keep on flowing. No signals. And this is the interface F00 of the router. Traffic is going out of the router. This is the router. And this one is hardware queue. And this one is a software queue that you created for voice. And this is called PQ, priority queue. And you got the other queues. Some queues are very fat, like this. See, it's too fat than the other queues. Now, you will put the business related traffic in this queue. And you will put the other identified traffic, which is important in this queue. and all other unidentified, but it's a traffic of your network. Now, when voice comes, it will enter this queue. Anyone enters in this queue, no speed break, no signal, they keep booming. And this bandwidth is always reserved. But whoever enters here, they cannot just go like that. Now, this has got more weightage, let's say weightage 7, weightage 6, weightage 5. Based on the classification, I have classified business traffic, important traffic, unidentified traffic. So for all business traffic, I place the traffic in this queue. And if there is traffic in this queue, these guys should stop. There's a red signal for them. So now this guy is going to keep going through this. And when this queue is empty, now there's a green signal for this guy. So here goes. All that who was waiting, the packets which were waiting in this queue now goes out. When the queue is empty, then comes this guy. And then it goes in round robin. Again, go to 7, 6, 5, 7, 6, 5. That's how it is. You see, there's a signal for every other passengers other than the king's family, even in networking. Now we are going to see these things in action in more detail as we are going through this chapter. Quality of service, in my word, if I need to say, quality of service is adding additional ability to the router so that router can work a little bit more intelligently. By default, router will treat all traffic same. By default, router don't know that this is important traffic, that is traffic which cannot be recovered, this is tiny traffic, this is a very big size traffic. No. By default, routers can't differentiate, so they can't provide different level of service. By default, no. It's like olden days India, where people were all in villages, not many people were in city. So there was no need for signal, there was no need for lanes, no need for traffic control. All can use always the road whenever they want and whatever they want, the way they want, because the roads are always empty. In general, without any QoS, routers are like that. Routers are like without any speed breaker, without any signals, without any lanes, without any traffic control. It is the FIFO, first in, first out, followed by default when there is no traffic engineering. See, this quality of service is of three types: integrated service, differentiated service, first in, first out service. This is no QoS. That's the default type of QoS. First in, first out. Whichever comes first will be served first. If you go to shopping mall in India, you can see this FIFO. In shopping mall, you can see when you are billing now, you may be having just only one product to bill. But the guy in the front have got one big basket of product. Not one, two trolley of items to bill. Two trolley of items. Trolley full, one full trolley vegetables, one full trolley other provisions, etc. But you got only one small product in your hand to bill. You have to wait. That is FIFO. You have to wait till this fellow in the front with the two trolley finishes his billing. This fellow see that you have only one product, but he will pretend as if he has never seen you. He will pretend as if he never seen you. He is not seeing you. And sometimes even if you ask, hey, I have only one, let me. You want some people say, no. I also want to go. That is what Indian humanity. No common sense, no humanity. Okay. That is what called as FIFO. First in, first out. Whoever comes first will go first. If that happens in networking, see what will happen? A big fatty FTP traffic. A bandwidth hunger traffic is in front. And the voice traffic, tiny traffic is at the back. What will happen? On the receiving side, the voice receiver cannot hear well because the packet will get lost. Why? Because of the fatty bandwidth hunger, FTP has blocked the path. That's why you have to do quality of service. Oh, you are a fatty fellow, wait here. Let the tiny teeny kid pass through. That is quality of service. Hey, he has got just one product, man. Let him get the bill done. You wait. Just one. Who should say this? The one who is billing, the vendor. He will also don't say that. Then what it means? It means that there is no QoS, there is no quality of service in that shop. See, in the networking, you have to have quality of service. Only then you will get a decent voice. Voice communication will be clear, decent. Few years back, when we were trying to improve the network using quality of service, it was not fully improved. On those days, we used to hear a robot talking to us. Actually, it will be your friend talking to you, but it will sound like a robot. Initially, it was good, and after some time, it became robotic sound. After some time, no sound. After some time, again, it comes normal. What does that mean? In the path somewhere, there is no good flow for this voice. To avoid all this metallic sound, robotic sound, delay, drop, we have what? PQ, priority queue, for voice and video and for UDP. You see here, this FIFO is not good. You need to first classify the traffics, and based on the classification, based on the traffic that you have identified, you have to provide some special service, like putting them in a priority queue or some reserved bandwidth queue. Very important. On each router, if you go and configure QoS, if you go and configure QoS on each router, we call it as diffserv, differentiated service. Whereas inserv is end to end. Diffserv is hop by hop. Hop by hop quality of services, differentiated service, diffserv. So each router need not to provide same service. It can be different also. Yeah. The service need not to be same on every router for that same traffic. For example, your friend is with you. When he is with you, because he is your friend, you give him very good service, treatment. You treat him very well. Now, when your friend goes from your house to some other place whom he do not know, you cannot expect the same type of treatment there. Your friend may not, he cannot expect the same treatment because he is not with someone he know now. Earlier he was with you, so you gave best treatment. But now he is with someone whom he do not know. Likewise, every router may not be in a position to give similar treatment. For example, you have three layers in your network: access layer, distribution layer, and core layer. You see, in access layer, you may give very good treatment, but in distribution layer, you cannot provide the same treatment. Why? Distribution layer is meant for many layer 2 segments. Many access layer will be connecting to distribution layer. So you cannot provide same level of treatment. If it is available, you can give, but if not, you need to provide service for all VLAN members, all traffic coming from access port, access layer. So you may wish to provide little lower treatment in the distribution layer than the access layer. For example, on the access layer, you might have said priority 7, sorry, priority 4. You said what? Priority 4 for one of the traffic. When the same traffic comes to distribution layer, you give priority 3. That's what you want to give. That is what called as diff serve, differentiated service. Diff serve is the widely seen quality of service. Diff serve is the widely seen quality of service. Int serve, integrated service. Integrated service is not possible in all type of network, and it is not possible to provide insert for every customers in the internet. What it is? Insert is integrated service, end to end. There are a lot of selfish people ruled the countries. Different countries were ruled by different selfish people. In India also, there was one selfish leader. There were maybe many you know. I know one person. When that person wants to go to his secretariat, his or her secretariat, whoever it is, right from Gopalapuram or whatever Puram or whatever, I don't know exact name of the place, from there to secretariat, the road will be blocked and no one can use it. This person, when he or she in the bathroom only, they will block the road from their house to secretariat. And then this person will come out and slowly get into the car and wave the hand as if someone is happy to see and go slowly to secretariat. After reaching secretariat, they will release the road. They will allow the people, common people, to go inside the road. That is what called as insert, end-to-end reservation. Is this possible for every person on earth? No way. Not possible. Maybe for one or two people you can give. Not for everyone. So we don't have this insert quality of service widely in use. Diff serve is widely in use. What we are learning is diff serve. For insert, if you are in a service provider track, you will learn insert, which is nothing but MPLS TE, MPLS traffic engineering. That is insert. Insert, diff serve. 3, 4. 3 type of QoS. All right. See, what is quality of service? The ability of a router to identify the different type of traffic and provide different levels of priority, treatment, service is quality of service. By default, router don't know to differentiate. By default, router never gives different level of priority. Making the router to do these things is what we call as quality of service. But one thing we should know. Quality of service is a solution for small congestion, once in a while congestion. Every time congestion, quality of service is not a solution. See, in In a country like India, which says, we are grown in this and that, every time congestion, and they will only follow quality of service. What quality of service? Speed breaker, more number, more signals, more diversion, more one way. No, that is what they do in networking also. Instead of upgrading their device, instead of improving the path with more bandwidth, what they do? They do quality of service, create more lanes, QoS, skews the packet, drop some packets so that congestion can be avoided. Is dropping a packet a good quality of service? See, you have to drop some packet. You cannot avoid congestion without dropping. That is what they claim it as a solution now. Quality of service will drop packet. You can tell which packet to get dropped if there is a congestion. That is quality of service. If you don't do that, it will drop even the important traffics. When the congestion happens, if you don't have QoS, if you don't have quality of service, routers will drop important traffic. So what is quality of service doing for you? When the congestion happens, it protects the important traffic from getting dropped by dropping the less important traffic. Is this quality of service? But this is what called as quality of service. This is okay once in a while, you see, but there cannot be a solution permanent. Ever congestion, then you cannot go for quality of service. You go put some overbridge, underbridge, increase the bandwidth, make the road broad. That is real quality of service. That is real quality of service. So in networking, when there is congestion, always don't say we will do quality of service. Because quality of service will only protect those important traffic by dropping the less important traffic. You have to drop some traffic to easy the communication for important traffic. Once in a while, only my network faces congestion. Then you can enable the quality of service and keep it ready so that when congestion happens, this quality of service will take action. What it will do? It will put all the voice traffic in the priority queue so that it will never be slowed down or dropped or delayed. It will drop some bad, less important, unidentified traffic so that the most important identified traffics will not get dropped. Once in a while only the congestion happens. Then you can definitely go for quality of service. Once in a while. But always congestion? No. The best QoS is upgrade your nexus, upgrade your port throughput, link speed, bandwidth, right? This is an introduction to QoS. Now, in quality of service, these are the things that we do. First one, we classify. We differentiate the traffic. That is what classification. After classifying, you mark it. Marking is nothing but you give some weightage. You give some value, number. Smaller the number, less weightage. Smaller, less. That is marking, classification and marking. Next is traffic policing and shaping. What is traffic policing and traffic shaping? Traffic policing is you drop the less important traffic. You drop it completely so that congestion can be reduced and the important traffic will not get dropped. That is traffic policing. That is traffic policing. You drop it. What is traffic shaping? You don't drop, but you put more speed brake. Meaning, for less important traffic, when congestion happens, less important traffic, you make them to wait for a while. You slow down. You slow those less important traffic down. You make them to wait in another queue for some time till the important traffic pass through and congestions go down. That is shaping. Shaping is you don't allow them to go fast. They were coming fast, but when the congestion happened, you said, hey, slow down. But the important traffic, you don't ask them to slow down. They are still going on the fast speed. That is shaping. Whereas policing is when congestion happens, you say, hey, go away from the road. You are not supposed to use the road. There is a congestion, out. Dropping the traffic. That is called dropping. The traffic is lost. That is policing. Traffic policing is you will definitely have a lot of loss. Shaping is you allow the important traffic to pass through as normal, whereas the less important traffic you make them to slow down. You make them to wait in the buffer. You put them in a queue which is having less bandwidth and make them to wait in the queue so that the congestion can be avoided. Congestion can be reduced. After that, you allow them to pass through. That is traffic shaping. For example, you have subscribed for 100 meg internet. You have subscribed for 100 meg internet. 100 meg. What if your network is generating 200 meg? Your network is trying to send 200 meg, but you have subscribed only 100 meg bandwidth with the ISP. So what ISP will do when they get more from you, they won't shape, they will police. They will drop all the excess traffic coming from you. ISP is going to drop all the excess traffic that is coming from you, which is what called as traffic policing. Whereas if you do traffic shaping, you would have avoided traffic policing. What is traffic shaping then? On the edge of your network, the edge router where the WAN is connecting to you, on that edge router, instead of sending 200 meg, you only send 100 meg, and the excess you slow down. That is shaping. You don't want to drop, but you want to slow down and send within that 100 meg limit outside. That is what called as traffic shaping. Right. So traffic policing is done on the provider side. Traffic shaping is done on the customer side. Customer limiting the flow within that agreed limit by slowing down the traffic is what called as shaping. Queue managements. We have different type of queue. One of the queue is priority queue, another one is weighted fare queue, another one is class-based weighted fare queue, and another one is low latency queuing. We'll see all of them. How do you avoid congestion? When you know the congestion is going to happen, either you do policing or shaping. That's how you manage congestion. Link efficiency. Improve the link's bandwidth so that you will not experience congestion all the time. Now, all these things we are going to see in this quality of service chapter.